Alright, hello everyone and welcome back. Okay, so far we learned how to integrate rational functions using partial fraction decomposition, which belongs to case 1 category, right? So let's now focus on case 2 category. Now under case 2 category means in the numerator we have the polynomial with the largest degree, right? So if you look at the rational function here, in the numerator we have a third degree polynomial, in the denominator we have a second degree polynomial. So numerator is larger than denominator in terms of the degree of the polynomial. So this is case 2, right? What do we do here? Well, first we have to find out the partial fraction decomposition. So let's find the decomposition, okay? Because it's not going to be a huge change from case 1. I mean the integration. So we can do the decomposition in this video. So let's do this. First we perform polynomial lone division, so x cubed plus 2x square minus 3x plus 1, and outside we have x square minus 3x minus 4. So we compare the first two terms, x cube and x square. So to create x cube out of x square, we have to multiply by x. X times x square is x cube, x times negative 3x is negative 3x square, x times negative 4 is negative 4x. Now we subtract, right? I will do this very fast because you have already seen this, right? Now you subtract. If you subtract, x cube cancel out, 2x square subtract minus 3x square will give you 5x square, minus 3x minus 4x will be plus x, right? Minus 3x plus 4x it will be, and 1 comes for free. Alright, so now if you compare 5x square and x square, it's just you have to multiply by 5 to create 5x square out of x square. So multiply back by 5. So 5x square, 5 times negative 3 is negative 15x, and 5 times negative 4 is negative 20. Now again you subtract. If you subtract, 5x square cancel out, x minus minus 15x is 16x, 1 minus minus 20 is 21. Perfect. Now here this is a first degree polynomial, but the device is a second degree polynomial, so we cannot move further on. So remainder is smaller than the divisor, so that's the remainder. This is the remainder. We stop our lone division here. Then the basic decomposition is q is x plus 5, q is the quotient, plus remainder is 16x plus 21 over x square minus 3x minus 4. Alright, so here we now have a case 1 rational function. So we do the partial fraction decomposition like we do in case 1. 16x over 21, factor the denominator as much as possible. So we'll get x plus 1, x minus 4. Now the decomposition is x plus 5. So this is distinct linear factors. So it would be like a over x plus 1. Let's choose x minus 4. A of x minus 4, no particular reason, but it's just I like x minus 4 in the beginning because it matched with my key. That's the secret, okay? Alright, no big deal. Alright, so this is the basic decomposition. Now we have to evaluate a and b, right? So to evaluate a and b, we can just use this small part. You don't need to use the whole rational function, whole decomposition. So we decompose 16x plus 21 over x plus 1 times x minus 4 as a over x minus 4 plus b over x plus 1. So to find a and b, we multiply the whole decomposition, both left hand side and right hand side, by this big denominator. So we have 16x plus 21 left on the left hand side, a times x plus 1 and b times x minus 4. You have already seen this a lot, right, in my video series. Now the magic numbers. To find a, we can use x is equal to 4. So if x is equal to 4, if you substitute x to be 4, left hand side 16 times 4 is what? 64. 64 times 21 is 85. And 4 plus 1 is 5. So 5a, a is 17. Okay, good. Now to find b, we can use the magic number x is equal to negative 1. If x is equal to negative 1, left hand side will be what? 5, right? 16 times negative 1 is negative 16. Negative 16 plus 21 is 5. So negative 1 minus 4 is negative 5. So negative 5b. Nice. B is negative 1. Perfect. Now the big complete decomposition is, so let's write the problem. So the problem we had is x cubed plus 2x square minus 3x plus 1 over x plus 1, x minus 4. So if you decompose this, we get x plus 5 plus a is 17 over x minus 4, b is negative 1 over x plus 1. This is the complete decomposition. Alright, so now we want to do integration. So we have to integrate the left hand side with respect to x. So instead of integrating the left hand side, we integrate the right hand side. So we can integrate separately each term. So x plus 5 separately, and plus 17 over x minus 4 separately, and 1 over x plus 1 separately. We can integrate them separately. Now the only difference from previous problems that we did in previous videos is that we have this extra quotient part, right? Because we are dealing with case 2 now. In the previous integration videos, I had only case 1 problems where there was no quotient, of course. Now, as you can see, the only difference is how do we integrate this quotient. I mean, for a quotient, you always get a polynomial. So it should not be a big deal to integrate quotient. No magic tricks, just use basic integration tricks to integrate the quotient. Okay, so if you integrate x plus 5, x square over 2 plus 5x. Now if you integrate 17 over x minus 4, 17 natural log absolute value of x minus 4 minus natural log absolute value of x plus 1. And don't forget plus c. Alright, so that's the answer. No big difference, okay? There's no big difference at all except in the decomposition. So in case 2, in the decomposition, you will get a quotient. In integration, the difference is just you have to integrate that extra quotient part, which is super easy because they are just polynomials. Okay? Alright, so that's it what I have for this video. So officially, integration by partial fraction decomposition video series ends here. Now what I'm going to do is, when I have time, what I'm going to do is I'm going to start making videos where I solve partial fraction decomposition problems, full partial fraction decomposition problems. I mean, I will have the integration, decomposition, everything there in those videos, okay? Because in previous videos, at certain times I only focused on decomposition, and then I only focused on integration. Now from now on, when I have free time, I will make videos so that I solve a full problem in a one video. Okay? Alright, thank you very much. Bye bye.